Thank you very much. Good afternoon. My name is Asma Abahussain. I am a professor of geology, geochemistry, and coordinator of a program, Environmental Science and Natural Resource Program in the College of Graduate Studies, Arabian Gulf University, Kingdom of Bahrain. The title of my presentation is Groundwater Quality in West Asia Region, Experience of Bahrain, Kuwait, and Saudi Arabia. The content of my presentation is the introduction, then water resource in the GCC country, agricultural sector water demands, and then the groundwater quality in Bahrain, Kuwait, case studies of Bahrain, Kuwait, and Saudi Arabia. And actually it was 3 abstract, and they told me to make it 3 in 1. So excuse me if it is a little bit longer than the others. West Asia region is this region. It's a classification of the Univ, and we are, as a university, a collaborating center for Univ, so that's why that classification. And GCC country is the 6th country from West Asia. It's Bahrain, Kuwait, Saudi Arabia, Qatar, United Arab Emirates, and Oman. And our university is a regional university, so we are not national one. So the case studies is from our research program in the university, beside the case study from my student that I am supervised. GCC country is an arid and extremely arid environment. The rainfall is less than 100 millimeter, and the evaporation is very high. It's more than 3,000 millimeter a year. And as this is the situation, there is no surface water, and mainly we are dependent on the groundwater to meet our need for the water resources. So mainly for this region, the groundwater is the main resource. And beside that, we have the desalination and treated wastewater. The groundwater is flow from the western part of the Arabian Peninsula. I think this one is working. Yes. The groundwater is a flow from the western part of the Arabian Peninsula toward the eastern part, and in some area it's reached the surface through the natural springs. In the past 4 years, in the past 4 decades, the need for the food security promote decision makers to encourage agriculture through subsidies and incentives programs. So most of the water uses is used for the irrigation. And from this example, this is an example from northern Saudi Arabia. It shows that as a result of the large scale of expansion of farming activities with substantial irrigation, it's the agricultural sector or the agricultural area is increased tremendously within time. So unfortunately, the groundwater requirement for agricultural sector were exaggerated by the poor irrigation practice, high water requirement to crops, lack of agricultural water tariff, lack of monitoring of quantities consumed, and insufficient water use due to traditional irrigation practices, and there is a lack in the assessment and reporting for water quality. Our university is, as I mentioned, this is the area, and this is the West Asia area, and here is the collaborating center for Univ, and our university is the main one for the GCC country. And we are working together with them in a project which is called the GEO project. I think some of you are familiar with it. Since 1997, till now we are working on GEO 5, GEO 6, sorry. And beside this kind of reporting activity, being with them in this process, we learn a lot regarding the type of assessment and how we use data for the assessment to communicate the case studies to the policymakers. So we are all the time trying to, now in this 2 days we are learning about the data, the water quality, but we need to move from this side into the knowledge, into to communicate to the policymaker. So we need to convert our data to information, to assessment, to knowledge, so the policymaker can take a wisdom decision for our society. So why we are measuring? Because we are measuring something that if you are cared for something, you measure it. You measure it, you can manage it well. The measurement, so we have in our department, we are tackling the issue of the water from two angles. The first angle is the measuring, because it is very important for us to have a capacity building, to build capacity for our students to know about the data and the indicators and such as. And from the policymaker, we are working with them in the line of assessment. So the three case study, it's from Bahrain, Dammam Aquifer, Kuwait group, from Saudi Arabia, SAG. This is our teamwork in the university, and these are the work of my students. We did all the chemical analysis, beside the bacterial analysis, as well as some heavy metal analysis, and to calculate all the requirement chemical analysis for those three aquifers. The data were compared with the national standard. The data as well we study the phases of the water, the Richard diagram classification for the type of the water, doing the irrigation water quality index, drinking water quality index, etc. For Bahrain, Bahrain is a small island development state. And Dr. White, I told him that you'll find something new about, you can add it to your presentation later on. Bahrain is, Kingdom of Bahrain is located in the Arabian Gulf, and the land area of 765 square kilometer, and the name of Bahrain is, it means the two seas. One is the fresh water that meets the seawater. So in Arabic, Bahrain, that means two seas, and this is because of the structure of Bahrain is a domal structure, in which it has in the northern part a lot of fractures that reach the aquifer, and this caused the water to flow as natural springs. From the past, since the water level is very high at that time. And that's why Bahrain called the island of million of palm trees, because of the availability of the water in this small island. Remember, we are in a very arid environment, and this water being there give Bahrain a very specialized, and we have a lot of historical temples. We have a lord called Enki. This is the lord for water and earth. Unfortunately, with the oil, when it's fortune, but in the same time, when oil exploration came to the area, the technology for digging the boreholes increased. So in 1925, the number of the wells was only one wells only. In 2000, it became 1,600 borehole well. So this increase in the number of boreholes due to the increased population, increased the demand for water, for urbanization and industrial, etc., result in decrease of the water level and increase in the same time of the salinity. The natural springs to the left, and then in the 19th, in the 16th and 17th, and in the 19th, most of the natural springs were dried, and it's not only the natural springs, it's the surrounding habitat and the ecosystem services, we lost it with them. And for the agricultural area, which is located in the northern part, the salinity of the water that comes from the western part is increased from about 3,000, it was 3,000 milligram per liter, to 6,000 in the 2001 year, and in the same time, the seawater intrusion start to hit our coastal aquifer. And in the recent study, 2010, the salinity of the water increased and reached up to 10,000 in the area, in the agricultural area. We did as well the type of water and the distribution, spatial distribution of the other. I have no time to explain it, but I will skip and concentrate on some very important. One thing else, we found that in the eastern area, there is a bacterial contamination in the groundwater, although it is a confined aquifer, but in this area we have the treated wastewater plants, the central one, and maybe it is the cause of the pollution. Climate change will affect as well the groundwater resource in the country, and you can see from here that there is an evidence for us that there is increase in the heat, and this all will affect the agricultural sector by the precipitation, increase in temperature, and overall as Dr. Makki mentioned, that the groundwater will be affected by the seawater intrusion. Second case study is from Kuwait. It's my student, whom I the main supervisor. In Kuwait, it's very extremely arid environment, and there is no activity for agriculture. But the governments, as I mentioned, try to have some food security, and it's allocate two agricultural area, one in the north and one in the south. So our case study is from Al Wafra area, which is located in the south. The difference in this area, the water table or the aquifer is unconfined aquifer. So any activity from the surface will affect the quality of water in the aquifer. And the same story regarding the increased number of the borehole wells. And this is due to the increase of the agricultural area. It was 11 square kilometer in 1973. It increased to about 200 square kilometer in 2010. And the study shows that the results shows that there is an increase in the total dissolved salts concentration for the groundwater within time, and reach in the time we did the investigation to more than 9,000 milligram per liter or ppm. So it is very saline water for irrigation. But the good thing is the soil is sandy soil, so it might be help in reducing, and there is some crops that resist the salinity. And the same thing, the other thing that the study found that there is an increase in the salinity toward the western part of it. And this is due to the presence of the the lakes, the evaporation lakes of the Wafra oil field. And that's mean that any operation nearby the agricultural area, especially when the aquifer is unconfined, it will affect as well the water quality in the area. The irrigation in some part of the Al Wafra area has resulted in increasing the salinity of the soil. And you can see from here, it's the crust with the saline crust is affecting. Remember, it is an agricultural area, so any salinity, increasing salinity will reduce their productivity. So we are losing the agricultural area, besides we are affecting our groundwater. And this is schedule what happened in this kind of activity. So wherever you are irrigate with saline, you are salinizing your soil, and you, in order to get rid of this saline, you need to irrigate more to leach it, and maybe it causes for you waterlogging. Then with the evaporation increase so you are all the time degraded your groundwater, and at the same time you are increasing the desertification. And increasing desertification, you are not affecting the productivity, the desert area, or what you are affecting as well the biodiversity, and reduce the carbon sequestration in the plants and in the soil. So you are, everything is increasing the other thing. You are losing the productivity of the soil due to desertification, losing the biodiversity, and increasing the impacts of for the climate change. We have been approached by environmental authority. In that time, when we finished the first study, they asked us to do an investigation about bacterial contamination. We didn't, in the first study, we didn't take into account the bacteria, but they told us that we have a problem here. There is a lot of septic tanks in the Al-Wafra area, and those septic tanks are unlined from down, and due to maybe we will have a bacterial contamination, especially that we have 1,700 farms, and each farm has 2 to 3 septic tanks in the area. So we did the investigation for another student, and he found that the level of E. coli contamination in 40% of the wells exceed the permissible standard. And the majority of the contaminated wells were located less than 60 meters from the sanitary landfill. So we have another problem in the area, which is it needs a regulation to have those kind of sanitary landfills to be away from, or a distance or a buffer from the wells that we have. The third case study is from Saudi Arabia. Here is my student Sanad, and we did the same. I just want to run this from this part, and we did this, and we have the spatial distribution. Wherever there is yellow, that means below the standard. Anything red, higher than the standard. The size of the circle, meaning the concentration. So we have the distribution, and we found as well there is a contamination from nitrate and from bacterial in some wells. And the dangers of that is, although those groundwater wells is reach down, and the depth of some boreholes is about more than 500 meters. But the dangerous part of it is some of those wells have water with less than 1,000 ppm. That means it's used for drinking. It's not only used for irrigation. So we did all the analysis, and we used the irrigation water quality index for the FAO, and it's according to this kind of indices. It is of moderate suitability for irrigation, but still we have a problem of contamination from bacterial in some area. In conclusion, although GCC are located in arid, just 1 second, I have this conclusion of my work. No, I have another part I would just like to share it with you before, since I have few minutes. Okay, in conclusion, the GCC countries are located in arid, but still the groundwater contribute most to their water demands. The transformation of dry lands into agricultural land with intense productive system has caused deterioration of the groundwater quality, and this caused quantity, and this caused the deterioration of its quality. Groundwater in the studied area, it was moderate according to the classification of irrigation water quality index, but the shallow groundwater aquifers in the region are susceptible for the bacterial contamination in it. I don't want to end my presentation with this, my research work, but what the country did regarding the water quality and the water quantity. We have a lot of regulation that's after the deterioration, what we found in deterioration of the water quality. A lot of regulation have been taken to reduce the agricultural subsidies. metering the groundwater walls, propose pricing. They didn't yet implement it, but they propose it. They consolidate the Water Resource Agency, establish higher water council, public awareness campaign, starting to replace the groundwater by the treated wastewater in the area, and changing the crop types to crop consume less water, and using modern technologies to protect the agriculture. Using this is in our university actually. We have a line of research in soil-less agriculture, and we distribute it, and we have a good result of it regarding the productivity, increasing productivity and water efficiency. So whenever we sustain our water, we are sustaining our agriculture, and then in the end we are having food security and water security in the end. What we need to do in the future, actually, I'm as an expert in the integrated water resource management, we are using a framework. We are all the time here speaking about the state of the problem. That means we need to have common indicators for the monitoring the water quality. We need, we call it MEDEC. MEDEC is from, this is from the European Environmental Agency, where they monitor and they report about the environment. They are moving from monitoring to data, to indicator, to assessment. And in the assessment, we are using what we call integrated environmental assessment. The assessment is supposed to be answer 5 questions. What is happening to the environment and why? This is the state, we call it. And what are the consequences? That means the impacts. And then what is being done? This is the response. And where we are heading? This is the scenario. And then in the end, what action can be taken? So we are not closing. And we are using the DBS, what we call DBSIR. I left this presentation so everyone can use it. And we not only look to the water, we need to look to the interlinkage between water and soil and air quality, and think about the water with the Millennium Assessment about the services and the human well-being, and very important for policymakers, the economic cost of the degradation. And before propose any policy, do the policy analysis. There is a methodology of it, and this methodology is in this website I'm sharing with you. It has all the modules with the PDF file, presentation, and everything in 6 languages. And thank you very much. Sorry for being long.
Thank you very much for very comprehensive data set and information. So I have to pass my chair to Yamashiki-san within 2 minutes. So I would like to accept 1 or 2 questions before.
Sorry. Thank you very much for your nice presentation. Actually, my question is for all 3 presenters. Like I saw that you discuss about water quality and quantity in different ways. I feel especially in groundwater there are 2. One is observation or measurement. Other one is modeling, because to see the distribution and things. But I didn't see much about that part in your 3 presentations. So do you have any comment on that one?
Okay, so you can
respond. Yes, we have modeling, but we have no time. Okay, we did in our region, in Bahrain, in Kuwait, we did all the time. We are doing the modeling, even for the movement of viruses. We are using software, ModFlow, etc. for the modeling, but there is no time for this. Not was the purpose of this symposium.
Your point is more technical point, or
yes.
general aspect for the modeling in the groundwater flow system?
Yeah, general.
Okay. So, sure.
Very quick question for the Bahrain case study. You said that the aquifers are confined,
Yes.
but then you said there were bacteriological contamination.
Yes.
So I wonder how they can pass through the groundwater and whether the wastewater is discharged directly into soil after treatment.
Across the
Yes.
aquitard.
Actually, we just have the data and we need to return back to the same area and to re-investigate it because it was very surprise for us. Very surprise for us.
Well, that's the important point that confined aquifers sometimes contaminated by the waste. So recently there are some data. It's possible for the shallow contaminated groundwaters may infiltrate across the aquitard into the confined aquifers, especially in the regions where the huge groundwater exploitation is performed due to enhanced recharge of the groundwater. So that need more investigations. Thank you very much.